Let's begin talking about the imaginary number system. First thing, I just want to give a brief history of number systems. And what I mean by that is, of course, we started with the kind of counting numbers, things like this. Eventually, we added 0 to that, but these are kind of your whole natural numbers. The next thing we added was the negative numbers. Right? This was really to describe what happens when you subtract a larger number from a smaller one, the negatives. The next thing we added were what are called rational numbers, things like this. Basically, fractions. They could also be written as decimals like that, but they are essentially numbers made out of whole numbers and their negatives. We could, of course, have done something like that as well. The next thing we added were the irrational numbers, things like pi, the square root of 2, the square root of 3, things like that. And really, fractions came about as a way to describe, portions of whole numbers, and irrationals came about because of Pythagorean theorem and saying, well, not all right triangle hypotenuse are going to come out to be fractions. The last and most current or most recent number system added are what are called the imaginaries. And the imaginary numbers are defined in this way. They're given the symbol I for imaginary, and they are defined as I squared is equal to -1. And that's new. We've never had a number that when multiplied by itself is a negative. Whenever we square numbers, we get a positive. But what this allows us to do then is to start to say, well, if I asked you the square root of -9, of course, up until now you'd say, well, that doesn't work. I can't type that in my calculator. But now we say this is the same as the square root of 9 times the square root of -1. The square root of 9 is 3, and the square root of -1 is I. Now, you don't have to go through kind of this simplifying radicals form every time. You'd say, well, what's the square root of -25? Well, the square root of 25 is 5, and because of that negative, we say 5i. The imaginary number system was really brought in. It has some applications, dealing with electricity and circuits and things like that, but also has some graphical applications helping us to find where things get close to touching the axis. So in all honesty, it really doesn't do itself any good calling itself the imaginary numbers, because students will always think, well, who cares if they aren't good for anything? They are. They have applications. Let's look at a couple more properties of the imaginary numbers. So, if I were to say, what's 4i plus 2i, we actually almost treat it as though the i's are variables. We say, well, I have 4 imaginaries plus 2 imaginaries. That's 6 imaginaries. If I were to say, well, 3 plus 2i plus 7 minus 5i, we combine the stuff that's not imaginary, so 3 and 7 is 10. And then we combine the 2i and the minus 5i, so minus 3i. So if we had something like 6 plus 4i minus 10i, well, there is no other non-imaginary other than 6, and then 4i minus 10i is -6i. So that's pretty easy to do, to combine. You just got to keep the things that are imaginary together, the things that aren't imaginary together. Where it gets a little trickier is if I were to say 2i times 5i. Well, 2 times 5 is 10, and I times I is I squared. Well, remember, by definition, I squared is equal to -1. So it becomes 10 times -1, which is -10. Okay, let's do another one like that. Let's make it a little bit bigger. So we're going to expand. We take and multiply. 4 times 3 is 12. 4 times 4i. Now remember, you can't add those together, but you're saying 4i's is 16i. And of course, we move on to the inside. 2i times those. So 2i times 3 is 6i. And then 2i times 4i is 8i squared. Well, let's make a pass through this and kind of simplify. 12 plus 16i and 6i is 22i. And then 8 times I squared, remember this is -1, so it's like -8. So our final 12 minus 8 is 4. Our final answer would be like this. When we have a mix of numbers like this, where we have part that's real and part that's imaginary, we call that a complex number because it's got 2 pieces to it. Like this isn't complex because this ends up just being real, but this is a complex number down here. So really, when you multiply something out like this, you end up combining some like terms in the middle. And just remember, whenever you have an I squared, you should right away replace that with a -1. Let's look at one more type of question you might see. Let's say we had negative square root of 16 plus square root of -49 plus square root of 9 plus square root of -64. Now, a negative in front of a square root we've dealt with before. Square root of 16 is 4. This just has a negative out front. But the square root of a negative number, square root of 49, of course, is 7, but because it's negative, we put an I. Square root of 9 is 3. And the square root of -64 is 8i. Combine your like terms. -4 and 3 is -1. 7i and 8i is 15i. So just remember, if the negative is out front, that does not make an imaginary number. If the negative is inside the square root, that does.